network, but yeah, it's good enough to get by for a while.
Right?
Yeah. All right. So this is what we're going to do tonight. First, do a quick review of what we talked about in this class so far. We've discussed a little bit about how computers work. We talked about all the different parts that go into a computer and how they work together. And then we talked about software. So after we have the physical hardware, we talked about all the software we can put on it, starting with application software. Then we talked about, starting with system software, like the operating system and utilities. And then I talked about application software. I've been using the analogy of a fish tank. The hardware was our tank. The water would be like the operating system. The fish is our application swimming in the tank. And then we've got utilities like a pump and maybe some gravel on the bottom and things like that. So that's what we've talked about so far. And then we finished up the last section of the course by talking about multimedia, like images, videos, things like that, and audio. And we also talked a little bit about devices, which is what your reflection was about today. So starting in this section of the course, so now we switch gears again a little bit. Now we start talking about the internet and networks and communications with computers, which is one of the really interesting things we can do with computers today, right? When I was a kid, we all had computers in our houses, but they didn't really connect to each other. There really wasn't an easy way for different people to communicate with computers. It really wasn't commonplace to do that. Mostly, I think I used my computer when I was a kid to play games and maybe write a document for schoolwork or something like that, but that was pretty much about it. Nowadays, we all use our computers on the internet, the World Wide Web. We use our computers to print things, wirelessly. We use our computers to browse the internet and buy things. Go to Amazon.com. I'm sure a lot of you bought your books for this class online. So all kinds of cool things that we can do with the internet, the World Wide Web, and networks in general. So in order to talk about communication and networks, I'm going to start with a discussion on how these networks work. So we're going to talk about how computer networks work from a very low level. So I'm going to start you with the very basics on how this communication over a wire actually happens. We're going to scale it up and start talking about specific network components that you might find in a business or in your home. And I'll try to tell you a little bit about those different components. And then next week, so after we talk about how networks actually work and how communications actually work over long distances, next week we talk specifically about the World Wide Web and the internet, and we'll talk a little bit about how to use the World Wide Web appropriately in academics. After next week, we have our next test. They come real quick, right? One after the other. So after next week, we'll have a test on those topics, on the internet, the World Wide Web, and how networks work. So again, it's a nice short little test, just like the last one, almost more like a quiz. That'll test you on just those basic concepts that we discuss in class. Make sense? Good? All right, so let's get started. Okay. Wait a minute. There we go. All right, when we talk about networks, by the way, I did this in PowerPoint so you don't have to suffer through my drawing on the whiteboard again. Terrible drawer, I know that. So when we talk about networks, we're talking about multiple computers or multiple devices. And I shouldn't say computers anymore, right? I should say devices, because a lot of us use network with things other than computers that are sitting on our desk like the ones in this classroom. All of these devices that we've talked about all connect to networks, right? Your cell phone, for example, does that connect to a network? It sure does, right? What other things in your home might you have that connect to a network other than a cell phone?
Well, a computer.
Yeah, your computer, your printers, right? Printers is the big one now. They all do wireless. The TV? Somebody say TV?
Yeah.
Yep, so the TV, that's a good one. Even your DVD player, right? Yep.
Fire extinguisher.
Yeah, fire, right? So if you have a burglar alarm or a fire alarm, that can connect through the internet to some monitoring center. Instead of using old-fashioned phone lines, now they can use the internet for sure. They can even use cellular now to do that stuff. So all kinds of things. But whenever we talk about multiple computers communicating with each other, we're talking about networks. So from a very basic level, if I take a bunch of computers and I connect them together, we have a network. What I'm depicting here on the screen, your book talks about, is a bus network. I'm going to talk about three different what they call topologies. What does the word topology, you think, mean? What does topographical mean or something like that? What does that mean to you? It's like the surface or the structure, right? So the structure of a network, there's three basic structures that people usually refer to. And I don't know why they still talk about these in these textbooks, because you'll find out in a minute we only really use one in the real world. But back in the old days, this was what networks looked like. You would have a single bus or a single wire, and all the computers on the network would connect into that wire. And that's basically how it worked. So I'll ask you a question. But God, this thing is really high up. But if I were to cut this wire right here, what do you think would happen?
Everything will stop.
Everything would stop. Would this guy be able to talk to this guy if it were cut right here?
No.
Yes.
Yeah.
It would?
Yeah.
It would, for sure. And these guys, they would be able to talk to each other, right? So we'd still have communication on both sides, but this guy would not be able to talk to this guy, right?
Oh, yeah.
Does that make sense?
It makes sense.
Yeah. So if this connection gets broken anywhere along the chain, weird things start to happen. When I think of this type of network, which is a very old type of network, when I think of this type of network, I think of Christmas lights. Anyone ever put Christmas lights up? One goes out, and randomly a bunch of other ones go out, but not all of them go out, right? How do you figure out which is the bulb that went out?
Good question.
I'll tell you how I figure it out. I throw the whole thing out because I get sick of it, right?
Yeah, mine do.
Yeah, once one goes out, you just say, the heck with this, I'm throwing it out. Same thing with these. I mean, we don't throw out the network, but it makes troubleshooting very difficult, because if a bunch of computers can't talk to each other, you're never really sure which one is broken. So all kinds of problems can happen. So it's not a very good network topology. Another one, so years later, after the bus network came out, years later we had a common network topology called a ring topology. And in a ring topology, basically what they did is they would set these computers up in a daisy chain. So each computer would connect to the next. So for example, if these 4 computers in the front of the room were a ring topology, there would be a wire from computer 1 to computer 2, then another wire from computer 2 to computer 3, and so forth. So think about this. If I cut this connection right here, can this computer talk to this computer if I cut it right here?
Yes. It can't?
You say yes, right?
Yeah.
Where would the traffic go?
It
can't
would go the opposite way.
You got it, right? It just has to go the long way, right? So in theory, it would work. If I cut it in 2 places, what happens?
No.
Now I'm back to that problem, right? So this is called a ring topology.
I have a question.
Yes,
What was the first one called? The
Bus.
definition? Bus topology?
yep, I wrote right up there on the top, bus.
Plus what?
Bus topology, T-O-P-O-L-O-G-Y, topology. All right, so we got a bus and a ring, and we're talking probably 1980s is when this was popular. That's the last time this was real, although there's still companies that do this. IBM was big on this topology a long time ago. But so this is how networks evolved. A long time ago, this is what we had. We had bus and ring topology. Moving forward in time, now we have something called a star topology, which is a little bit better. So with a star topology, we have some kind of a central wiring device in the middle. So there's some kind of device in the middle, and all the computers connect to that one device. Does anybody know what that device is called? Put the answer up there, though, right? The switch. How many of you guys have heard that term with computing? A switch.
Switches and networks.
Yeah. So how many of you guys have a network at home? Some of you do, right? You pay Comcast or Verizon or somebody for a connection at home to the internet. And a lot of you probably have a switch. And all of the computers on your network connect to that one switch. So, you know, if you've got 6 computers in your house, you don't run a cable from computer 1 to computer 2, and then from computer 2 to computer 3. You have to have a cable to every single computer, right? Now, if I cut this cable right here, can these other guys still use the network? They sure can, right? So it's a little bit more impervious to problems on the network than the old days when we use these other network topologies. There's one disadvantage here though, right? I have to have a cable going to every single computer, right? So this room has how many computers? 30 computers, right? So when they wired this room, all 30 of these computers have to have a wire that goes from these computers all the way back to a closet somewhere where they plug into that switch. So they all have to plug into some switch somewhere. How big do you think that switch is? How many computers are in this room? 30? How many rooms are on this floor? Probably 5 or 6 with computers, right? We're talking a couple hundred computers in this building. So somewhere there's a switch that's got a couple hundred wires sticking out of it, right? Not like your home, right? How many wires might you have at home? Although most of you probably don't even have wires, right? What do you use at home? Most of you are wireless, right? How many of you guys still have wired connections at home? Still run cables around your house? All right. Yeah, so 2005 called and they want their network technology back, right? But yeah, it's all the rage now to do wireless. Everybody does wireless now. But wireless works exactly the same way. This switch in the middle, instead of being wires connecting to it, it's wireless signals that are connecting to it. But it's the exact same concept. So your wireless switches that you have at home are really the same thing as this, but instead of plugging wires in, you're connecting to that switch, okay? But it's the exact same concept. So the switches that you have at home are star topology, just like you see up here. So this is how modern networks work. If you go out and get a job and work somewhere, there's a 99.9% chance that they're going to be using a star topology or a star network. And of course, your computers here in the school and your computers at home, they all work that way. Now, let's say we've got two different networks, right? Most of you don't have this at home, but think about school. Think about this building. We've got this floor with all of these different computers all connected to a switch. But then we've got another building across the way, right? There's another building or that building down there. They've got their own networks with their own little switches and their own star topology, right? We have to somehow get these two networks talking to each other. So the way we do that is we put in a device called a router. How many of you guys have heard of a router? A lot of you probably have, right? That device you have at home, you probably call it a router, right? When you got it from the cable company or when you go to Best Buy and say, I need something at home to connect to the internet, they sell you a router, right? A router is a device that allows your local network, by the way, it's a term that we use to describe these. These are called local area networks. So anytime you have a network of computers connected in these little star topologies that I'm discussing, this is a local area network or a LAN. You will see that term on the test, by the way. So different LANs can be interconnected by these devices called routers. So a router's job is to connect different devices. By the way, a router not only connects different networks, but it connects those networks to the internet as well. That's why you have one at home. You have to have a router at home in order to connect your little network at home to the wider internet. Okay? But this is why we don't have to have, 500 cables in this building all bundled together going to the building across the grass over here. We don't have to do that because they all connect to a router, and that router aggregates everything to another network. So all these different networks connect to one another through routers. Okay? So important takeaway so far is our three network topologies, which is bus, ring, and star. The fact that any star network is called a local area network. That's when computers are all sort of in the same building or in the same smaller area. We call that a local area network. Stars topologies have a central wiring device called a switch. Some of you may have heard the term hub. I used to talk about hubs, but hubs haven't been used in 15 years. But in the old days, that used to be a hub, but today it's a switch. And the only two devices you really need to know so far is what a switch is and what a router is. At home, you probably have a router and a switch in one device, right? So you've got one little device. The cable company or the phone company called it a router, but it's really a router and a switch all in one. Because it's a router to connect you to the internet, and it's got 4 ports or maybe 8 ports to allow you to connect computers to it, or it might be a wireless hub so that you can connect devices to it wirelessly. So we've got our switches, we've got our routers. Whenever you interconnect multiple LANs, that overarching network we call a WAN. What do you think WAN stands for?
Wide area network.
Right, that's our wide area network. So we've got a local area network, and then we've got a wide area network. Make sense? All right, so that is a brief tour of how networking sort of works, but I'm going to talk about this in a little bit more detail in just a few minutes.
You said which one, the one that we had to know for the test was the router and the switch?
Yeah,
Right.
well, so most students can figure out WAN and LAN, right? That's easy to remember.
Mm-hmm.
Most students can remember ring, bus, and star because it looks like a ring, looks like a bus, looks like a star.
Mm-hmm.
But router and switch, a lot of students confuse those. That's why I mention it.
Okay.
To be fair, when you take the test, you're going to see this drawing and you're going to have to label this stuff. That's basically what I do.
Okay.
Okay? Don't worry, I'm not turning it off yet. In addition to, so in this network, there's 2 types of local area networks that we talk about, that your book will talk about. The first type is called a peer-to-peer network. So a peer-to-peer network is where all of the computers on the network are equals, right? So all the computers on the network can all do the same thing. They're all equal to one another. So for example, on this network, this is a peer-to-peer network. There's no one in charge. All the computers can talk to each other. There's nobody who's responsible to do anything. Every computer is responsible for itself. How many of you guys have multiple computers at home? A lot of you do, right? And how many of you have to log into your computer at home? You have maybe a password on that computer. The password that you use on the first computer, does it work on somebody else's computer?
No.
No. Unless you happen to make it the same, right? But you would have to do that, right?
Mm-hmm.
So all these computers sort of are in charge of themselves. They're their own boss, right? Now, think about this room. How many computers do we have in this room? We got 30, right? We already talked about that. Let's say we were a small company, and the 30 of us in this room all worked in this small company. And your job was to make sure that everybody could log into these computers. So, and let's say one of the requirements is we never know where people are going to sit, right? So we got to make sure everybody can log into every computer. Everybody has a different account. That means how many different accounts does every single computer have to have?
30.
30, right? Okay. So let's say somebody leaves the company, right? Let's say somebody gets fired and we kick them out. We got to make sure that that person can't log into any of these computers. How many computers do I have to go to in order to remove that account so we can make sure that person can't log in again?
One.
One? Really? So if I remove that account, yeah, we got to go to every single computer to remove that account, right? What if we had 1,000 computers in our company, right? So if we had 1,000 computers and somebody left the company, I'd have to go around to 1,000 computers and change the passwords, right?
Mm-hmm.
That would be ridiculous. People be leaving and coming. Say what?
I'm listening.
Yep, yeah, so it's a big pain in the neck. So one of the things we need to get around that problem is instead of having a peer-to-peer network, we use what's called a client-server network. So in a client-server network, some of your computers are in charge. They do something for the network. So for example, one of these servers, and by the way, servers, you don't have to have each type of server in each network. You can have different servers in different places. And they can all talk to each other because it's one big, happy, wide area network, so everything can talk to one another. But your book talks about a server called a network operating system. So a network operating system is a server that's responsible for things like user accounts. So if you work somewhere and you have a network operating system, that means that if you have a user account, you're actually logging into a server when you log into a workstation. So when you try to log into a workstation, the workstation is taking those credentials and asking a server somewhere if you're allowed to log in. That way we only have to maintain that stuff on one computer, on one server, right? So in my company of 1,000 computers, I only have to add and delete user accounts one time on one server. Makes a lot more sense, right? Without client server, that would be impossible. Another type of server that your book talks about is a file server. So you'll hear two terms, or you'll see two terms in your book. One is a network operating system, which manages user accounts. The other one is a file server, which is a common place to store files. How many of you guys have a file server at home? Any of you guys have one of those? They actually sell them now at Best Buy. You can buy these little devices that store files on your network, and you can copy files to it over the network. A lot of folks don't have them yet. They're not very useful for most people. But let's say you work in a company. You would want all the files that everyone uses to be in some central file location. That way, whenever somebody needs a file, we don't have to worry about which computer it's on. We all go to the same place to get those files. So if there were 1,000 computers in the company, and you know you're looking for a certain document, you don't have to go look in 1,000 different computers for that document, right? That would be ridiculous. So you can go to a central file server. So most